intercept. Let's see what the next question is.
The next question, write down the coordinates of the turning points of the graph of F.
We are to write down the coordinates of the stationary point. We are to write the coordinates of the stationary point, the turning point. So let's write our equation again. It's f at x equals x cubed minus 6x squared. And then remember, we are to find a stationary point. For stationary point, we derive 3 times 1, that is 3, and then subtract 1, it's x squared, minus 2 times 6, that is 12x. This is our gradient. The derivative, it's a gradient of a tangent. And then this is the gradient of a tangent where? At the turning point. The gradient of a tangent at the turning point is 0. So we are to let our gradient to be 0. Therefore, we are going to have 3x squared minus 12x equals 0. We equate our gradient to 0. Let's divide by 3 then. It's 3x squared minus 12x equals 0. Let's divide by 3. We are remained with x squared minus 4x equals 0. Right, I just want us to look at this. You can't say, oh, 3x squared. 3x is a common factor. 3x is a common factor. We can't do it like this. It's x minus 4 equals 0. You can't say that, let us divide by 3x first. This is wrong. This is wrong. We've got x squared, that means we are going to have two values of x. You can't divide like this. So let's factorize them here. It's x into x minus 4 equals 0. And then we solve. X is equal to 0 or x is equal to 4, that one. These are the x values at the turning point. X values at the turning point. Let's find the y values. For y value at the turning point, we substitute these values into the original equation. So our original is f at x equals x cubed minus 6x squared. Right, we are going to use these values of x to find y value at the turning point. Let us firstly find, using this, it's f at 0, that value of x, into 0 minus z all squared. Therefore, the answer is 0. F at 0 is 0. Let's find y, where x is 4. It's 4 cubed minus 6 times 4 all squared. And then the remainder here will be negative 32. So our y value at the turning point would be negative 32 if x is equal to 4. If x is equal to 0, our y also will be equal to 0. Therefore, our turning points, we have 0 is to 0 and the other one is 4. If x is equal to 4, y is negative 32. Those are our stationary points. Right. Before you sketch this graph, again, you will have to look at the shape. The value of A. The value of A is positive. Therefore, our graph will be increasing. Our graph will be like that. It will be an increasing function simply because our A is greater than 0. So our graph will be increasing. So let us sketch this graph. Right, that's our Cartesian plane. And then let's indicate all our points. We've got the x-intercept and also the y-intercept. Our y-intercept is here. And also there is a turning point there. Remember that our graph is increasing. So if there is a turning point, obvious, it will come from this side because it's increasing. It's increasing. It's increasing. Right. The other x-intercept is that one. So it's 6 here. And then the turning point, we've got the turning point 0 is to 0 and 4. There is another point, another value there, which is 4. It's 4 is to negative. 4 is to negative 32. 4 is to negative 32. So that means you are going to have the turning point at 0 is to 0 there. And then remember it's an increasing function. So now when it reaches that point, it will have to go down. Up to here. Up to there. 4 is to negative 32. 4 is to negative 32. So we are going to have a turning point there. Your graph moves from 0 up to that point down there. Move from 0 up to here. And then again, from there, it goes up to cut that point where x is equal to 6. Right, you have a turning point here. And then this is 6 here. Function of f, 6 is to 0. Our turning point. Our turning point is 4. It's 4 is to negative 32. Also another turning point, which is also the x-intercept. 0 is to 0. So we've indicated all the points. Your graph is now complete. Let's continue.
Given f at x equals to x cubed given f at x equals x cubed minus 5x squared plus 7x minus 3, which is equals to, open in brackets, x minus 1 all squared multiplied by x minus 3.
Right, that's what it's been given here. The first question.
The question says, draw a neat sketch of graph of f. Clearly indicate the intercept of x's as well as the coordinates of the turning point.
Right, we are to sketch this graph. This is the same as that. So let's take this as it is. Our f at x is equal to x minus 1 all squared. So it's x minus 1 into x minus 1 into x minus 3. And then we are to sketch this graph. Looking here, we need to find x-intercept, right? So we have f at x, which is equal to, for x-intercept, we let y to be 0. I mean, for y-intercept, we are to find firstly the y-intercept. So we are going to let x to be 0. So our equation is x cubed minus f plus 7x minus 3. So if you are to put 0 in the place of x here, if you are to put 0, our y would be negative 3. Therefore, the y-intercept will be 0 is to negative 3. Let us now find the x-intercept. Right, for x-intercept, we let y to be 0. Our y to be 0. Therefore, x minus 1 into x minus 1 into x minus 3 will be equal to 0. The roots are 1 or x equals 3. We've got two equal roots. X is equal to 1. Right. And then our x-intercept. Our x-intercept 1 is to 0. 1 is to 0. And the last one is 3 is to 0. These are our x-intercept. So now we are to find the stationary point. Stationary point. F at x equals x cubed minus 5x squared plus 7x minus 3. Noticing that in this function we have two equal values of x, which are two equal roots. That means we are going to have a turning point there. Let's see. For stationary point, we derive this will be 3x squared minus 2 times that, it's 10x plus 7. This is the gradient of a tangent. The gradient of a tangent, since we are to find the stationary point. The gradient of a tangent at a turning point is 0. So you let the gradient to be 0. It's 3x squared minus 10x plus 7. This is equal to 0. And then the next step, we are to factorize. It's 3x minus 7. Is it minus 7? Into, remember, that is obvious. It's x minus 1. So, which means, let's check for the signs. It's minus 7x minus 3x, which will give us minus 10x, yes. And then we solve for x. 3x is equal to 7, or x is equal to 1. Let's divide there. X will be equal to 7 over 3. Right. And then now, these are the values of x. Let's find the y values at the turning point. We substitute by these x values into the original equation. So let's find f at 7 over 3. F at 7 over 3. So in the place of x, we put 7 over 3 minus 5. 7 over 3 plus 7 times 7 over 3 minus 3. And then you are to find the remainder there.
It's negative 32 over 27.
So this is the value of y when x is equal to 7 over 3. So let's see what will it be if we put 1 there.
Into 1.
Oh, we are substituting by 1. Right. And then our remainder. So, if you put 7 over 3, your y will be that. If you put 1, your y will be that. Therefore, turning points, we've got 1 is to 0. 1 is to 0. As you can see here, we had 2 equal roots. And the other turning point is that one. 7 over 3 is to negative 32 over 27. And then we've got all the points. Now we are to sketch the graph. We are to sketch the graph. Increasing. Increasing. A is positive, so it's an increasing function. And it has got a turning point. where y is equal to 0. Which means this is our x-intercept, and at the same time there will be a turning point. 1 is to 0. The other turning point down there, the other turning point, it's 7 over 3. 7 over 3 is to negative 32 over 27. What about the y-intercept? The y-intercept is negative 3. The y-intercept is negative 3. So, the y-intercept is negative 3. Negative 3. 0 is to negative 3. So, here we have the turning point. 1 is to 0. Let's write the x-axis passes through there. And then we are to write this x-intercept. 3 is to 0. 3 is to 0 here. So your graph is now complete. Your graph is complete. It's an increasing function. You have just run your graph, indicated the turning points y-intercept and also the x-intercept. That's how your graph will be looking like. Right, for now, we are going to stop here so that we are going to move on and see on how now we were sketching the graph here. Let's see how are you going to use your graph to answer the questions if you are being given a graph. So now let us just stop here and then we are going to continue to interpretation of a cubic function.